Hi everyone, Mrs. Danielson here, and today we're going to talk about the complementary angles identities. They're really great identities to have. They're easy to use, and it's good to be familiar with them because we see questions based on these identities quite often on the SAT and the ACT. So it's good to know these, be familiar with them before you go in and take either of those tests. Okay, so the complementary angles identities are that if W and Z or two angles are complementary, then that means the sine of one of the angles equals the cosine of the other angle. Okay, just that simple. If they're complementary, the sine of one equals the cosine of the other. Now, that that's true also means or implies that the secant of one equals the cosecant of the other, and the tangent of one equals the cotangent of the other. Okay, so all three of those things are true. Although most of the time what you're going to see is you're going to see that the sine of one equals the cosine of the other. That's the one we see the most on the SAT and the ACT. But we're going to take a minute here and we're going to explain why this is true and do a couple of practice problems. So I've gone ahead and I've drawn a triangle in here. It's a right triangle. So this means that W and Z are complementary. Those two angles have to add up to 90 degrees because it's 180 degrees for a triangle, and if we subtract 90 for the right angle, it leaves 90 degrees for W and Z. They are thereby automatically complementary. Okay, so if they're complementary, that means we expect, based on this identity, that the sine of one is going to equal the cosine of the other. Okay, so let's check that out and just make sure that's truly the case. All right, so we're going to start with sine of W and cosine of Z. So sine of W and cosine of Z. Let's see if that's really true that they are equal to each other. So the sine of W, sine is opposite over hypotenuse. Opposite of angle W is going to be B, and the hypotenuse is C. Cosine is adjacent over hypotenuse, and the side that's adjacent to angle Z is going to be B, and the hypotenuse is C. So right there you can see they are equal. They're both equal to B over C. So that makes that first statement true. Sine of W is equal to cosine of Z. Is the second one also true? Let's just check that out, right? Cosine of W and sine of Z. Is that statement also true? Right? Cosine of W would be adjacent over hypotenuse. Adjacent to the angle W is A. The hypotenuse is C. And for sine, opposite over hypotenuse. Opposite angle Z is B. No, opposite angle Z is A. And the hypotenuse is C. So there we go. They're both equal to A over C. They're equal. So that makes both those first two statements true. And those are the ones you're going to see the most often, right? Those two opposite angles, they're complementary, and the sine of one equals the cosine of the other. Okay, these other two are implied in that identity. We don't see them quite as often, but just so that we feel comfortable using them and understand them, let's just check those out really quick. Okay, so secant of W and cosecant of Z. Okay, our secant is hypotenuse, right, over adjacent. And cosecant is hypotenuse over opposite, right? Just using our reciprocal identities. Okay, so the hypotenuse is C. Adjacent to angle W is A. And opposite angle Z is A. Those are both equal to C over A. So that statement is indeed true. Okay, and tangent and cotangent, right? So now we're looking at tangent of W and cotangent of Z. Let's check that out. Is tangent of one angle equal to the cotangent of the complementary angle. Okay? Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Okay, so for angle W, opposite is B, adjacent is A. And for Z, adjacent is B, opposite is A, and they both equal B over A. So all of those statements, we checked all 4 of those statements, and indeed, they all worked out to be true for this right triangle. W and Z are complementary angles. Okay, let's work out an example now. Let's say we're given the question stated like this. If X and Y are complementary angles, and cosine X is equal to 0.5, what is sine Y? Okay, let's think about this for a minute. Why don't we go ahead and draw a triangle to help us work it out. Do a little bit better job than that. Okay, so we have an angle X and we have an angle Y. They're complementary. They add up to 90 degrees. And they tell us the cosine of X is 0.5. That means the cosine of X is 1.5, which is adjacent over hypotenuse. So that means this side is 1 and that side is 2. Okay, the sine of Y is opposite over hypotenuse. Opposite, the angle Y is 1 and the hypotenuse is 2. So that means the sine of Y is 1/2, which is the same as the cosine of X. Okay, excellent. Okay, complementary angles, right? One cosine, one is sine, and they're the same. Okay, let's try one that's phrased a little different. Find a value of X that satisfies the equation. Sine of 24 degrees equals cosine of Y. So what's the case when this would be true? When does sine of one angle equal cosine of another angle, right? That happens when one angle and the other angle, the X and the Y, the 2 angles are complementary. That's when this happens. So that means this second angle, that angle needs to be 90 minus 24 degrees, right? Y needs to be the complementary angle to 24. Okay. This statement is true when it's the cosine of 66 degrees. So Y equals 66 degrees. Okay, and there you go. That's all you need to do, complementary angles identities. Okay, pretty easy to use and definitely useful if you're preparing for your SAT or your ACT. Thanks, everybody.